What if the ocean's hidden conveyor belt, the Atlantic Meridional Overturning Circulation, or AMOC, slowed to a crawl or even stopped within our lifetime? Imagine pond-lined Cornwall under snow, the Baltic frozen for months, and winters that bite like Siberia while summers still sizzle. Tonight, we're going inside Earth's heat engine and what a stall could mean for Europe and the world. Far beneath the surface drama of waves and storms, the Atlantic is running a colossal, quiet machine. Think of it as an escalator for heat. Warm, salty water rises north along the surface. Cold, dense water plunges into the deep and slides back south. This loop, the AMOC, is the reason Western Europe is dramatically milder than regions at the same latitude across the Atlantic. It's why London winters rarely look like Labradors, and why agriculture can exist at latitudes that otherwise should feel subarctic. It's not a single current, but a linked system. Trade winds shove warm water westward. Coastline geometry funnels it into swift boundary currents. The famous Gulf Stream is part of the broader picture. Evaporation cranks up salinity, and frigid polar air densifies that salty flow until it sinks, tugging the conveyor onward. For thousands of years, this cycle has quietly tempered Europe, a natural central heating system humming along beneath the news cycle. Forget rocket science. This is kitchen physics on an oceanic scale. Warm water holds less density than cold. Salt increases density. At high latitudes, winter air chills salty water enough that it grows heavy and sinks like a stone, dumping surface heat into deeper layers, drawing more water in behind it. The seesaw between heat, salt, and density keeps the overturning stable, until something puts a thumb on the scale. Here's the catch. Pour enough fresh water into that northern engine, from melting ice sheets and amplified rainfall, and you dilute the salt. Lower salinity means lower density. Lower density means less sinking. Less sinking means less pull on the surface conveyor. The escalator slows. Slow it enough, and the steps barely move. Look around the North Atlantic today, and you'll find the signs. Fresher surface waters in key sinking zones around the Labrador and Greenland seas. Heat anomalies and salinity shifts that nudge the system away from its robust state. Monitoring arrays, moorings, Argo profiling floats, satellite altimetry, showing variability that looks like a loss of resilience. The system recovers more slowly from small pushes, a classic warning in complex systems. This isn't a Hollywood cut to black. It's the slow tightening of a hinge as the door strains against a new weight. And it leads to a question that feels less hypothetical every year. How close is the threshold? If you're into clear, visual breakdowns of big space and Earth systems, tap subscribe now. We decode the universe every week. The obvious headline is colder winters across northern and western Europe. But it's not the whole story. Paradoxically, the planet keeps warming overall. That means Europe can get sharply colder in winter and still experience serious heat waves in summer. Wild contrasts. Worse winters. Dangerous summers. Meanwhile, climate patterns globally don't stay politely local. The ITCZ, that equatorial band of storms, tends to shift, rearranging rainfall belts. Monsoon systems in India, West Africa, and parts of South America can weaken or migrate, affecting water, food, and public health for billions. The U.S. East Coast gets walloped by regional sea level rise when the Atlantic slope rebalances. Coastal cities see faster flooding risk than global averages imply. Nutrient pathways in the North Atlantic reorganize, stressing marine food webs and fisheries that depend on them. An AMOC slowdown is not a Europe-only story. It's a planetary domino. Picture Amsterdam in midwinter after a pronounced weakening. Canals glazed more often for longer stretches. Average January temps that bite harder. Municipal budgets turning into winter response budgets. Copenhagen's harbors rimmed with ice more frequently. Oslo wearing a deeper frost for longer months. Heating grids, road salt, snow management, and emergency healthcare all stretched at once. Jump to July. The same region gets a blistering heat dome. Not every year, but often enough to feel new. Crops, already stressed by delayed spring warmth, get a scorching summer punch. In vineyards at the margins, varieties shift or vanish. Farmers experiment with greenhouses, windbreaks, and new irrigation schemes. Insurance markets scramble. Tourism sways between winter shutdowns and summer surges, while coastal towns eye storm surge maps with a fresh kind of attention. There's a reason this isn't guesswork. The Atlantic has become one of the best instrumented parts of the global ocean. Satellites track surface temps and sea height changes down to centimeters, tiny slumps and swells that hint at circulation strength. Argo floats dive to 2 kilometers and back, taking temperature/salinity profiles that feed into data assimilation models. Moored arrays across strategic latitudes measure currents directly, like listening to the ocean's pulse. Glacier and ice sheet monitoring tracks the freshwater input that can tilt the density balance. We also cross-check against paleoclimate, the Younger Dryas. An abrupt cold snap near the end of the last ice age is widely tied to a major Atlantic circulation disruption. Ice cores, sediments, fossilized microplankton, the planet's archives tell us that the oceans can jump states faster than our intuitions like. People crave a calendar. When does what happen? But complex systems shift in steps and stalls. You might see a decade or two of increasing winter severity for Northern Europe and more frequent summer extremes, with fisheries and farming nudged into new realities. Hydrological whiplash, drought/flood cycles reshuffled across basins, hard-on infrastructure designed for the 20th century. Migration pressures that aren't apocalyptic floods, but a drumbeat of harder winters, pricier heating, stressed crops, and unpredictable rains nudging millions to move. Is a full off-state collapse this century guaranteed? No. Is a material weakening that significantly reshapes European climate risk plausible on policy-relevant timescales? Absolutely. The numbers matter because they translate physics into lives. Agriculture, growing seasons shift. Frost risk, windows change. Some regions pivot to cold hardy strains. Others invest in controlled environment agriculture. Energy, winter heating peaks spike. Grids need winter hardened reliability and more summer cooling capacity. Storage, interconnectors, and flexible demand become strategic national assets. Insurance and finance, premiums rise in places facing both colder winters and coastal surge. Mortgage and municipal bonds reprice climate exposures. Urban adaptation, northern cities invest in all-weather transit, resilient district heating, flood barriers, and emergency cold shelters, while coastal metros plan for compound sea level risk. All of this is manageable if planned for. It's chaotic if ignored. Can we do anything? Yes. There are 3 levers. Number 1, reduce the push. The engine falters when fresh water dilutes the sink. The upstream driver is global warming. Cutting greenhouse gases slows ice melt and precipitation shifts that freshen the North Atlantic. It's not instant, but it's leverage on the biggest lever. Number 2, adapt in place. Harden Europe's winter resilience while maintaining summer heat readiness. Weatherize buildings, modernize district heating, diversify power, wind, nuclear, hydro, storage, climate-smart farming, protected cropping, precision irrigation, new cultivars, regional seed banks, fisheries management that anticipates species on the move. Number 3, watch the gauges, expand, and fund the ocean observing system. The more precisely we track salinity, currents, and heat content, the earlier we see structural change, and the more targeted our responses. The AMOC isn't a villain. It's a giant, patient machine that made Europe's climate feel improbably gentle for its latitude. The story now is whether we push that machine into a weaker gear or let it lock into a state our cities, farms, and coasts weren't built for. Here's the most unsettling line in the ocean story. Once complex systems tip, they can stick, even if you remove the original shove. That's why monitoring matters. That's why planning matters. And that's why wait and see is the most expensive policy of all. If you want more crisp, visual explanations on the forces shaping our future Earth and deep space, hit subscribe and ring the bell. We turn the biggest what-ifs into clear stories every week. Picture a winter sunrise over the North Sea, the kind that puts copper on the water and frost on every railing. Beneath that calm, an invisible river is either carrying warmth north or not. Whether Europe feels like Europe 30 years from now may hinge on that hidden flow. Oceans write the climate. We write what we do next.